students. In this session, we are going to discuss about again operating system structures. In that, we are going to discuss about system program. So, what exactly is a system program? How it affects operating system? So, the textbook that you have to follow for operating system is the Operating System Principle 7th edition, and you could see the the picture here, which is reflecting towards this Abraham Shilbert and Galvin. So Galvin textbook is preferred, and you will have this logo there. So that is why I am using this logo. This refers to OS Operating System Principles by Galvin. And these are the two textbooks that you can follow for operating system. Myself, Dr. Shirisha, Associate Professor from CSC Department, MLR Institute of Technology. And coming to operating system structures, what are the system programs? So, system programs are nothing but it provide a convenient environment for the program development execution. If you write a program, so you need an editor and you load it and you run it, and you have to first compile it and then run it. So, what is happening is the program has been developed when it can develop only with the help of the system program. So, it is developed and executed. So, they can be divided into again these things. So, one is the file manipulation. As we have discussed in the previous session, in the system calls, how your files are being handled with the help of a system call. Here we are seeing with the help of a system program, with respect to the system program, that how the files can be manipulated. And status information sometimes stored in a file modification. So, this is nothing but information maintenance. Okay, that we have discussed there. And the thirdly, we are discussing programming language support. So, which programming language user prefers? So, that supports your operating system or not. So, that also we have to check it out. Next is program loading and execution. Whenever you have your program either in the main memory or in the physical memory, so how to load it, how to execute it, so that we need to take in care. And system programs also with respect to communication, like communication, again IPC come into the picture, again message passing and shared memories are coming into the picture. Next, background services, like you can see that few services will be running at the background of your operating system. Okay, either you have a mobile phone also, all the recently used applications or some processes been running in the background. So, for that also you need a system program so that it runs at the background. The best example for this background services will be like if you have Windows 32. So, Windows 32, it has to execute at the background unless your system is shut down. Whenever you have some process to execute, you should have this Windows 32 running at the background. Therefore, at the foreground, all the process or applications by the user will be executed. That's a background service. Application programs, any sort of application that the user uses like MS Office, PDFs, Android, mobile Android applications, okay, something like that, anything, okay, browsers, files, etc. And most users' view of the operating system is defined by the system programs, not the actual system call. So, most users' view is only the system program. So, when it comes to the actual system calls, it is taken care by the kernel, not by the user. But system program is taken care by the user and not by the kernel. So, system programs provide a convenient environment for the program development and the execution, as we have already seen this definition. And there are some more simply user interfaces to system calls, others are considerably more complex. So, if you use like open system call, if you are using, it's very simple. But if you wanted to execute a Windows 32, then how? We are not going to give any sort of instructions. They are complex, which are taken care internally. So, file management, create, delete, copy, rename, print. So, these are the few system calls that we have to use for manipulation of the files. So where you can create a file, delete a file, copy the file, renaming the file. So these are all modifications that the user can do with respect to the files. And similarly with the directories also. When you have a particular data stored, so in the form of files, so f1.txt is a file. But if you have f1.txt, f2.txt, some files like this, f3.txt, these all need to be stored at some place. So this is nothing but the directory. So you create a directory and put all your files which are related to that in a single location or a single place. So that is nothing but the directory. And you also can know what is the status of these. So that is how the status information can be maintained. Some ask the system for information like what is the date, what is the time, and what is the available memory, what is the disk space, number of users, like that. Such casual, such minimal information can be maintained by the they can be retrieved by the status information. And others provide detailed performance. So detailed performance is logging and debugging information. Anything can be again maintained by the status information. Simply if you give info, then it gives you the complete information about the system. So typically these programs format and print the output to the terminal and other output devices. So system programs or means what? Status information means just info or help. So something like this, if you give the system calls, what happens? These programs format and print the output onto the terminal. So this is how they can be used. Some systems implement a registry used to store and retrieve configuration information. So registry is nothing but again there's some sort of softwares will be having these directories. They will be maintaining such directories where we call them as a registry. They'll implement a registry which is used to store and configure the configuration which is maintained for compatibility towards the operating system. So for which we need this registry. Okay. So in somewhere or the other, the system call and the system programs are both related to each other, we can say. So coming to file modification. So what are the file modifications like copy, delete, create, rename, okay, or move, like this we have seen, right? So text editors to create and modify files. Special commands to search the contents of the file and perform transformations of the text. That is also possible. Programming language support is required where compilers, assemblers, debuggers, interpreters are provided by the programming language, that software itself, so that they can be loaded, they can be stored, and they can be executed with the accurate results. Similarly, program loading and execution where you need absolute loader and relocatable loaders, linkage editors and overlay loaders, debugging system for high language and machine language. Suppose if you don't have a software, so like Anaconda or Jupyter for Python, so can you write a Python code and can you execute it? No, right? So you need a specific software where it supports the programming language support is required, and that can be loaded and executed only once you have these loaders where you can load which is with respect to the softwares that you are installing. And similarly, the communication. Provide the mechanism for creating virtual connections, maybe virtual connections, remote connections among the process, among the users, and among the computer systems. Like if you have organization, the same organization branch you have in the other place remotely. So the data should be centrally maintained and it should be shared among these two organizations. So where communication happens in between the computer systems remotely, where we call them as a virtual connections. Okay. Nowadays after COVID, everyone is using an online platform where online is virtually connecting people around the world through virtual connections itself. So allows users to send some messages to one another's screens, browse web pages, send electronic mails, log in remotely, transfer files, whatnot. Everything is possible in today's generation where you are using machines. So if you see in future, we'll be getting a quantum computing where 100 times faster than the current processing can be done in future. This is where we are talking about the background service and application program with respect to the system call. So background services like launch a boot time. So your system has to boot. Okay, and they may be at the startup, then terminate. Some from the system boot to shutdown. Everything has to be maintained. There is a background process that should run for user to process its data. Provide facilities like disk checking, process scheduling, error logging, and printing. So, coming to especially process scheduling, we will be discussing in the second unit what are the different techniques we have and when we are going to implement them. So, printing also, some sort of input has to be given by the user so that system calls will be sent by the user to the kernel, so that print action will be taken place, right? So run in user context, not kernel context. So as we have discussed in the previous sessions, there will be two modes, user mode and the kernel mode. And the bit varies. If you are in the kernel mode, that will be a 0 bit. Whenever you are turning the kernel mode to the user mode, the bit changes to 1. So and vice versa. Both the ways you can use it. So that is, user can be either in the user or kernel mode. Known as services, subsystems, and daemons. So all these are nothing but the names for the systems, the host names that we can host system can be treated as a daemon or the subsystem or the services. Okay. Then finally, application programs. What is the application program? What are the applications that are used by the user? Is nothing but the application program. So don't pertain to system. System is not related to this, but you need a kernel support to use any sort of application run by the users, not typically considered part of OS. Launched by command line, mouse click, and finger poking. So anyway, you can use application program. Nowadays we got the touch screens also, so that you can move in between two fingers if you use to drag to zoom in and zoom out. Okay, something like that. Or scrolling. Okay, you need to move your finger, and just a command line instructions also can be given, like say suppose mkdir used to create a directory. Okay, cd change the directory. Okay, the like cat to display the file content, or simply a mouse click is also fine. So these are all different application support programs which requires all this. Okay. So what is operating system structure? So generally there are different ways. You have a simple structure like initial operating system that was used previously, that is MS-DOS. Okay, then more complex to the Unix, and layered and abstraction overview like Windows. And you have kernel for the Mac OS, you have a microkernel. So these are the different structures we are going to discuss in this session. So general purpose OS is a very large program. OS is a very large program where layer to layer, I mean the structure to structure of the operating system may vary. So if you see MS-DOS, if you see, it is written to provide the functionality in the least space. The space is very low. So what you have is ROM, BIOS, device drivers. Initially, you need to have a few device drivers, and then MS-DOS device drivers, then resident system program. On the top of all these three, application programs can be used. This is where you have a bottom-up approach from ROM BIOS to the application program. So this is not divided into module. MS-DOS, where you give completely the command line and the application programs will be executed with the help of command lines only. Although MS-DOS has some structure and its interface, level of functionality are not well separated. So the functionality is not just like your mouse click or not just like your Windows and Unix operating system, which we are using in today's generation. So MS-DOS was used very previously, and the drastic change from the MS-DOS to the Unix was changed very rapidly, and this has a limited hardware functionality, Unix also, and which is again very rapidly changed to Linux, and the original Unix operating system has a limited structuring. It has two separate parts. One is the system program and the kernel. What is the kernel? Kernel consists of everything below the system call interface and above the hardware. If you have a hardware, by using simply the hardware, no application program can be run. So what you require is operating systems. The kernel will be the heart of the operating system, where it helps the operating system to perform every task. Provides the file system, CPU scheduling, memory management, and all the functions which are required by the operating system. So that can be done by the kernel. So this is a Unix operating structure, where you could see here you have user here, and you have some sort of physical memory and device controllers and terminal control terminals. So all these are there at the basic level. If you have the resources, then the user can use those resources, and he can take help of the system call interface, so that when a user wants to fulfill some process or fulfill some task, it sends the kernel some information with the help of the system call interface. What signals, terminal handling, and character input output operating system, terminal, whatnot, everything, all these demand paging, virtual memory, swapping, file system management, everything is taken care by the kernel, and in between the user and the kernel, that could happen with the help of the system call interface. And on the top of when you have the resources and when it can support all this, so here Unix will support shell programming and command line argument, commands you can pass it in the command line. You have compilers and interpreter for Unix operating system, where it can compile the shell programs and it can run. And there are few system libraries which are required again for writing the shell programming. So system libraries are also supported for the Unix operating system. If you see the structure of MS-DOS, we don't have all this file system management, CPU scheduling, memory management, all this is not possible. But that is there in the Unix operating system. So let us then see what is the layered approach, which is again divided into different layers, like layer 0 hardware, and layer N will be the user interface. In between, whatever we have discussed, like protection, file management, information maintenance, okay, file manipulation, process management, device management, everything, each layer will be taken care. Okay, so this modularity layers are selected such that each user operates or functions the services only lower level layers. So if you have user level, so if you have this hardware, then only you can use the layer 1. If you have layer 0, layer 1, then layer 2 can be used. It is in such a way. This is called the layered approach. And this is microkernel. Like microkernel means whenever you have this Mac OS, so it supports the microkernel structure. So if you see here also it is supporting a hardware. For every operating system, initially you require a hardware. It can use a kernel mode only when you have a microkernel which supports the inter-process communication, IPC. Again, here it supports the message passing and shared memory techniques. Memory management, where allocation of memory is maintained using different techniques. Similarly, memory management, in what way, in what procedure you can have to store the data. Okay, that is memory management. CPU scheduling is where schedule the CPU with the help of some process scheduling methods. Okay, these are the three which microkernel also supports. And on the top of the kernel mode, you have is user mode. User requires the device drivers and user requires the file system, and then only he can run all these application programs. So the scenario is same, but the layer, it is not layered and it is not completely the Unix like structure. So this is like this structure. Okay, so coming to operating system generations, we have different generations, and they are designed to run on any class of machines. So generation to generation, you have it is varying. System must be configured for each specific computer site. So sysgen program obtains the information. So sysgen, it is like a system program where it obtains the information, and the configuration of that operating system with the help of the hardware is possible using the sysgen. There is a system generation. So it is used to build specific system specific compiled kernel. That means what? System specific means what? Wherever you are using any system with any sort of operating system, then it has to build on top of that. It should be reliable. Okay, compiled kernel or system tune. And this sysgen is also can generally more efficient code than one general kernel. So whenever you are using the sysgen, so on the top of this, whatever the structures we have discussed so far, so all these can be implemented. Either it is a layered approach, either it is a Mac OS like structure, or a layered approach structure, or the DOS structure. So all will be supported in this system generation program. So that on the top of this program only, a user and the kernel mode can communicate with the help of either the system call interface or with the help of any medium. Okay, system call or the system programs that supports process controlling and device management, etc., whatever. Okay, we have discussed so far. So that is about the operating system generation. So far we have completed the unit 1, where we have discussed about OS overview. Okay, initially, then we have discussed about the OS system calls, OS system programs, OS modes, different modes of operations like kernel mode and the user mode, and protection and security, and distributed system. Okay, and OS generation, system generation. Then we also have discussed types of system calls. Okay, so all this. So all these will cover the, this is all the second part, OS structure. Okay, so these are the few topics that we have covered so far. Hope you all understood the first unit. Thank you all.